So the third time's a charm. The reason the other video cut off where it did is because it didn't start, but I went 10 more minutes into the video before I realized that it wasn't recording me anymore. So picking up where we left off, if I graph this in my graphing calculator, this is what appears. So what we see is that we have a root at -2, and we have another root at +3. So we're going to work with one of those. I'm going to choose to work with the root -2. So I'm going to put that in a box there and do synthetic division. So I'm going to get 5x cubed minus 12x squared minus 23x plus 42. So bring down the 5, you get -10, -22, 44, 21, -42, and 0. And that is what should have happened because we knew that that was a root of it. So what we have right now is the -2 as a root gives us a factor of x plus 2. And now we have this quotient, and that gives us 5x squared minus 22x plus 21. Now I know that this is also going to factor, and I mainly know that because of what we just saw in our calculator, because I know I have another root at where x equals 3. So I'm going to rewrite x plus 2 because we already know that's a factor. And then I'm going to show I know that x minus 3 is a factor. And so if that's a factor of the circled trinomial, then the other part of the factor must be 5x minus 7. And if you were to FOIL that purple part right here, these two purple binomials, you would get that. And so this is f of x fully factored. So the fundamental connections for polynomial functions. For a polynomial function f and a real number k, the following statements are equivalent. X equals k is a solution or root of the equation f of x equals 0. And if k is a solution or root, then k is also considered to be a 0 of the function. And these are the 4 terms we've talked about for roots. And if k is a solution and a root and a 0, k is an x-intercept of the graph of y equals f of x. And x minus k is a factor of f of x. So find a polynomial function with leading coefficient 2, that's an important piece of information, that has the given degrees and 0. So we want a degree 3. We have a 0 at -1, so that gives us the factor x plus 1. We have a 0 at 3, so that gives us a factor x minus 3. And we have a 0 at 5. So I'm going to multiply these all together, and if I just do the first two, I get x squared minus 3x plus 1x minus 2x and now if I multiply that trinomial times a binomial, I'm going to get x cubed plus 5x squared minus 2x squared minus 10x minus 3x minus 15. And when I combine my like terms, I get x cubed plus 3x squared minus 13x minus 15. Now the only thing that's missing, so this is a degree 3, but what we don't have right now is a leading coefficient of 2. So I'm simply going to multiply this whole thing by 2. And so we would get that f of x equals 2x cubed plus 6x squared minus 26x minus 30. And if I were to now work in reverse and factor this whole thing, it would end up factoring to this right here. So this would be our final answer. And then this last one, we want a degree 4. that has roots of -3, -1, 0, and 5 halves. Now let's look at this 5 halves. If we know that x equals 5 halves, what is the factor going to look like that goes with that? And I want you to think backwards. If we had been solving for x, what would be the last thing that we had done? Last thing we would have done is divide by 2. So we're going to work backwards. And we get 2x equals 5. Now we know that we want this factor to equal 0, so we're going to say subtract 5, and we get 2x minus 5 equals 0. So the factor represented by a root of 5 halves is actually 2x minus 5. So for this polynomial, we're going to get f of x equals 2x minus 5 times x plus 3 times x plus 1, and if one of our roots is 0, then that factor is simply x. So I'm going to FOIL these two terms first, so I get 2x squared, and then I'm going to have 6x minus 5x, so that's plus x, and then minus 15. And now I'm going to put these two terms together, so that's going to be x squared plus x. And now I'm going to multiply the green times the blue. So I'm going to get 2x to the 4th plus 2x cubed plus x cubed plus x squared minus 15x squared minus 15x. And then when I simplify that, I get 2x to the 4th plus 3x cubed minus 14x squared minus 15x. And so does it meet all of our terms? Degree of 4? Yes, it is a degree of 4. And a leading coefficient of 2. And yes, so that would be our final answer. Find all of the exact values of the real zeros of the function. You may need to use your graphing calculator. So for this first one, I already have it put into my graphing calculator. I just need to make sure I select the right one. So I want this one. And I'm going to go deselect that one. So this one has a root at -3, and that doesn't look like it's exact, and that doesn't look like it's exact. So we're going to go ahead and try out -3. And I'm going to have 1x cubed, 3x squared, -3x, and -9. So So what this gives us is that this would factor to x plus 3, and then this quotient here would give us x squared minus 3. So to figure out what our other two roots are, if we're setting this equal to 0, we get x squared minus 3 equals 0, so x squared equals 3, and x equals plus or minus the square root of 3. And if we go back and look at our graph, this is plus square root of 3, and this one is minus square root of 3. So we have a total of 3 roots for this problem. X equals -3, and x equals plus or minus square root of 3, which makes total sense because we have a degree 3 equation. So it either has to have 3 solutions or 1 solution. And for this problem, we have it put into the calculator already. So I'm going to deselect this one and go and select this one. And let's look at the graph of it. Now this one's kind of ugly because none of these are pretty. But I'm going to go ahead and find this root right here. So I'm going to hit second calculate, and I want to calculate a 0. So it's going to ask for the left bound, and I'm at it. And then it's going to ask for the right bound, and I'm at that. And so what this gives me is that 0 is 0.6666667, which means that it's 2/3. So going back here, we have 2/3 as a root, and then we have 3, -2, 3, 1, -2. So bring down 3, multiply times 2/3, that gives us 2, 0, 0, 3, 2, 3, 2, 0. So remember how we did that last factor? This actually gives us 3x minus 2 as a factor. And then what we get for our quotient here is 3x cubed plus 3x plus 3. And we can pull out the greatest common factor of 3 from this one. Oops. And that isn't going to factor any further. And so if we wanted to find the other root of this, we're just going to go to our calculator and we're going to do another calculate. And this one's going to be really ugly. So we're going to calculate the other 0. So they want left bound, right bound, enter. So that other 0 is 0.602327, so we're just going to say it's 0.60. So our two roots for this problem are, oh, that's negative. Negative 0.60 and 2/3. Now the good thing is you are not responsible for knowing the rational zeros theorem and the upper and lower bound tests for real zeros. So last year what we made you do is you had to look at the first term and the last term and come up with all possible rational roots by looking at all these factors. So for this part A you would have had to use plus or minus 1, plus or minus 3, plus or minus 9, and test all of those using synthetic division until you found one. This year we're going to focus on using your calculators to at least help you get started. But you do need to know how to do synthetic division and you do need to know how to do long division.